Let's open up a simple project and discuss the basic features of a model network. Move the mouse up to the main menu and select File. The File menu contains familiar commands. Here we want to select the Open command. Chan keeps a list of recent files as a shortcut to locating and opening an existing model. Click on the onepawn.net file and have a look. Once you open a file, its path and file name are displayed in the Windows title bar, and the menu displays additional items that we will begin to explore here. There are two ways to work with your model data, as the network can be managed in list form or in a schematic. We'll start with the list form. When you click on the Edit menu item, a drop-down list appears. The Edit menu includes a few advanced features, including a tool that automatically assigns IDs to model features and a tool that is used for renaming elements. We will come back to those. For now, let's take a look at the file description. The file description is important as it helps you distinguish between your projects, including when viewed in the File Selector dialog. It's also used as a title on certain reports. You will be prompted for a file description anytime you create a new model. Another advanced feature and topic for later discussion is the watershed. We'll come back to that. It's more important right now that we dig into the framework of our model, which is based on the topological relationships between basin, node, and reach features. Let's start by discussing network topology. Click on that menu item. The left side panel displays a set of command buttons. We will discuss the use of the command buttons at another time. The right side panel displays all model reaches, and they're assigned from and to nodes in list form. For large networks, these lists scroll in a synchronized manner, and from these lists you are able to select existing reach and node elements for viewing and edits. When you click on an element in the list, the other list features are selected appropriately, and the command buttons at the bottom of the lists are populated with the selected element identifiers. You can either double-click a listed element or click on one of the three lower command buttons to view and edit data describing the selected item. Let's go ahead and look at some reach data. When you click on the command button for a selected reach, the reach components form is displayed. This form provides a list view of all elements that are contained within that single reach. Chan is powerful and unique in that any number of culverts, bridges, gates, weirs, orifices, and more can be placed in parallel within a single reach, and any number of weir, gate, and orifice sub-elements can be placed in parallel upstream or downstream to control flow through each element. We'll talk more about reach elements and the power of complex structures another time. Going back to the network topology form, let's take a look at the node upstream of the selected reach. Double-click on the node element in the From list or click on the lower command button and Chan displays the node form. As seen in the top panel of the form, there are a few different types of nodes to become familiar with. We will discuss those shortly. All types of nodes have elevations assigned for bottom, initial water level, and flood level, and some have tables of elevation and area or storage values. Click on OK to close the node form. Double-click on the node in the To list or click on the lower command button and Chan again displays the node form. Notice in the top panel of the form that this is a tailwater node. You can have any number of tailwater nodes in a Chan model. Tailwater nodes do not have storage, and the initial water level serves as a constant boundary condition for the duration of a simulation. Chan does allow for time-varying boundary conditions, but we will discuss those another time and stay focused on model framework. Click on the OK button to return to close the node data form. There's a lot of ground still left to cover as relates to the network topology form, network editing commands, utilities, and model reach and node data, but let's keep things moving. Click on OK to close the network topology form. Back on the main Chan window, let's pull down the Edit menu. This time we will move the cursor to the Basin topology menu item and click to have a look at basin and node assignments, which define the hydrologic framework of our stormwater model. The Basin topology form looks quite familiar, with command buttons in the left side panel and basin and node lists in the right side panel. Only a single command button is positioned below the basin and node lists because only basin data can be viewed and edited from this form. Select a basin and click on the lower command button and Chan will display the basin form. Data assignments for basins will be discussed in another tutorial, but at a glance you can see that each basin can be defined independently using a variety of hydrologic methods. For now, let's click on OK and return to the Basin topology form. Double-click the other basin to again display the basin form. Much of the data for basins is repeated. We'll show you later how to save time by using default values, global replacement, and importing data. That's a very quick overview of basin topology. Click on OK to return to the main Chan form. You're now familiar with the basic topological relationships that comprise a Chan model and how to work with the framework of a model in list form. In some cases, you may find this to be the most efficient way to construct your model. Alternatively, the model structure can be developed in schematic mode. We will explore that method in the next tutorial.